In Hyperledger Fabric, privacy is more than a compliance checkbox. Every architecture choice affects what data is exposed, retained, deleted, and audited. Add AI into the picture, and the risks expand from leakage to bias. That means governance has to be built in from the start. You now have the full Fabric picture: foundations, smart contracts, operations, scalability, governance, and compliance. This module shifts the focus. A network can be secure and auditable and still mishandle sensitive data. Privacy design is how you prevent that. A common mistake is assuming that because Fabric is permissioned, the data is automatically private. It is not. Fabric gives you strong building blocks: identities, policies, channels, private data collections, encryption, and storage choices. But privacy depends on how you combine them. Put data in the wrong place, replicate it too broadly, or define access boundaries poorly, and the ledger can preserve that mistake for years. Privacy has to be designed before production exposure creates business or regulatory risk. Privacy by design means privacy is built into the Fabric network from the first architecture decision, not added after deployment. Start by minimizing on-chain data. Store only what validation and audit truly require. Define the purpose for each data use and align retention to that purpose. Then enforce least privilege through MSP identities, attributes, chaincode logic, and application checks. For sensitive content, combine encryption, pseudonymization, private data collections, and off-chain references so the ledger can prove facts without exposing more than necessary. Before you design chaincode, decide what each data element is allowed to become. Classify it as public, confidential, personal, sensitive, or regulated. Then map why you need it, what legal basis supports it, how long it must live, who can see it, and whether it needs auditability. Those choices drive the storage pattern: on-chain, private data, off-chain, tokenized, or excluded entirely. In Fabric, schemas are governance decisions, not just code. Personal data needs special care. Once written to a ledger, it may be copied across nodes, retained for years, and difficult to erase. That creates privacy and compliance exposure, even in permission networks. Avoid placing raw names, IDs, health details, biometrics, account numbers, precise locations, or sensitive attributes on-chain. A hash is not automatically anonymous if it can be linked or guessed. Prefer minimal proofs, references, encryption, private collections, and off-chain systems where deletion and access controls are realistic. Fabric gives you two main privacy levers. Channels create separate ledgers for separate groups. That provides strong isolation, but too many channels become hard to operate and govern. Private data collections are more targeted. Selected organizations receive the sensitive value, while everyone on the channel records only a hash for proof. The design decision is not just about secrecy. It must balance who endorses, who audits, and how manageable the network remains. For many sensitive records, the better pattern is not to put the record directly on the blockchain. Keep it in systems designed to protect and manage data, such as databases, document stores, object storage, or regulated records platforms. The ledger receives only a hash, record ID, pointer, or signed reference. Later, an authorized party can hash the off-chain record and compare it to the on-chain value. That proves integrity, timestamp, workflow state, or consent, while deletion, retention, encryption, and access control remain off-chain. Pseudonymization and encryption are powerful controls, but they are not magic erasers for privacy risk. Pseudonymization hides direct identity, yet patterns can still link records back to a person. Encryption protects confidentiality, but only as well as the keys are governed. That requires disciplined key generation, storage, rotation, revocation, backup, and destruction. For sensitive workloads, use managed key systems, HSMs, separation of duties, access controls, audit logs, and regular re-identification analysis. Privacy controls begin before any chain code is written. Define the permitted business purpose for each data element and transaction. Capture the consent or legal basis that supports that use. At runtime, combine identity attributes such as role, organization, region, or function with application authorization and chain code rules. Then log purpose changes, consent updates, and access decisions. That audit trail shows that data was used within approved governance boundaries. Immutability gives blockchain its audit value, but it changes how retention works. In a normal database, records can be edited or deleted. In a ledger, corrections are usually new transactions, while the original data may still exist across peers, backups, snapshots, archives, logs, and analytics exports. For that reason, deletion has to be designed upfront. With highly sensitive data, the safest strategy is often not to write it to the ledger at all. In Fabric, deletion is usually a design decision made before data is written. Immutable ledger entries are not rewritten. Instead, you decide where sensitive data lives and how it can be made unavailable. Private data can be purged while hashes remain. Off-chain records can follow retention rules. Encrypted archives can be erased by destroying keys. Future views can suppress or correct exposed values. The strongest pattern is often to store only proofs on-chain and keep regulated content elsewhere under clear governance. Ledger data is especially attractive for AI because it is structured, consistent, and trusted. That same strength creates governance risk. Data collected to settle transactions may later be used to train models, score participants, or automate decisions beyond the original purpose. Pseudonymization may not be enough if patterns can be linked back to identities. Historical transactions can encode bias. Model outputs may also expose sensitive relationships, pricing strategies, or supply dependencies that were never meant to be inferred. Privacy-preserving analytics is not about blocking innovation. It is about setting guardrails for how data and AI are used. Start with access reviews, purpose checks, risk assessments, and approval records. Reduce exposure with techniques such as aggregation, anonymization, secure enclaves, federated learning, or synthetic data. Keep training datasets versioned and separate from operational ledgers. Finally, monitor model behavior for bias, leakage, weak explainability, and secondary use that was never authorized. Privacy in Fabric is a design discipline, not an add-on. Minimize sensitive data, keep it off-chain unless there is a clear reason to write it, and plan access, retention, purge, and erasure before production. For AI, govern consent, inference, bias, and explainability. Next, we connect these choices to enterprise risk and production readiness.